Alright, JP Geyer Partners. This is low impact development. Contents, introduction, storm management using hydrological cycle approach. LID design guides and objective comparison to LID conventional practices. Low impact development. Distribution microscale systems. Introduction. This course is adapted from Unified Facility Criteria U.S. Government, which is undistributed but is not copyrighted. Introduction. Definition of low-impact development is stormwater management strategically concerned with the maintaining of the storm of the natural hydraulic function of the site with achieving the natural resource of the project's objectives. Full environmental regulatory requirement. Low-impact development employ the very natural and built feature of the produce the rate of the runoff filter of the pollutants facility with the infiltrate of water into the ground by reducing water pollution, increasing the groundwater recharge. Low impact development helps to improve quality of receiving surface water, stabilize the flow rates of the nearby streams. Low impact development incorporates itself the overall site design strategies as well as highly localized, small scale, decentralized source control techniques known as integrated management practices. Integrated management practices may be integrated in building infrastructure landscape design rather than collecting runoff of the pipe with the channelized network controlling the flow downstream with a large stormwater management facility. Low impact development takes the decentralization approach with the dispersed flows of the managed runoff closer to where it originates. Because low impact development embraces a variety of useful techniques for the control of runoff, is designed to can be customized according to local regulatory resource protection requirements as well as the site constraints. New projects, redevelopment projects, and capital improvement projects can be also viewed as kind of the implementation of low-impact development. The small scale are the key elements going with the conservation, preserve the natural trees, vegetation, soil, maintain with the natural drainage patterns. Small scale control mimics the natural hydraulic processes. Custom site designs each of the site to help protect the entire watershed. Maintenance, pollution prevention, education, reduce pollution, educate loads, and increase the efficiency. Longevity educates involves the public direct runoff of the natural area with encouraged infiltrate, recharges the stream, the wetland aquifers. Part 1-2 background youth of low impact development. Low impact development was pioneered in 1990 with the Prince George County, Maryland. The Department of Environmental Resources of the Prince George County has a population over 800,000 of the land use of the county with a very diverse range of sparsely populated with natural and agricultural areas to densely populated urban center of the low impact development efforts of the Prince George County began with the development of the bioretention cell with a bioretention soil created place existing soil with a high porous soil mixture creating an area with a shallow depression for planting. The area is special with selective vegetation. Vegetation must be able to tolerate temporarily saturated soil condition with a as well as pollutants containing local runoff. What rains in prior retention area with the collect the runoff, the filter of the pollutants as water passes down through the soil with the coal. The county's initial experience of the bioretention full-scale effort to incorporate low-impact development with the county's resource protection program. In 1998, the county produced first municipal low-impact development manual. The latter explained with the National Distributed Local Impact Development Manual published in 2000. Feasible study was prepared with Low-Impact Development Center. 2002 provided guidance on how low-impact development can be used to retrofit urban areas. Numerous municipalities included Portland, Oregon, incorporated low-impact development techniques into their urban resource protection programs. Although low-impact development concept of techniques many of the planners in the United States, many of these techniques have been successfully used in Europe, Asia. For many years, the effectiveness of the project managing runoff, reducing construction maintenance costs, creating ancillary benefits of the such community involvement has created significant interest in low-impact development challenges to adapt these approaches and the techniques to the unique requirements of facility and wide scale. 1-3. The discussion provided the introduction of the guidelines integrated low-impact development planning, design, facility, regulatory resource protection program useful for the engineers, planners, maintenance personnel, regulatory compliance staff, the community outreach staff who want a basic understanding of the technical administrative concepts associated with the design, construction, maintenance of low-impact development features. And to answer the following question: what is low-impact development, and what value does it have with the facility owners? What are the basic planning, design, construction, maintenance, consideration? How can the approach incorporated into financial operation? What are success examples of low-impact development facility programs? Where can additional guidance be obtained? Low-impact development site design strategy. For the goal of low-impact development site design is to reduce the hydrologic input. Impact development incorporate techniques to maintain and restore the site with a hydrological and hydraulic function of the operative low-impact development site design. Minimize runoff Preserve existing flow paths, minimize the infrastructural requirement by construction, conventional site design, runoff, and energy may be increased with the result of the concentrated flow of the larger and more extensive stormwater infrastructure. Generally, the site design strategies for any project will adjust the arrangement of the building, roads, parking areas, and other features of the conveyancy of the runoff that is across the site. Low impact development site design strategies achieve all the basic objectives of the site design with all minimizing generation of runoff. Some examples of low impact development site design strategies include grade to encourage sheet flow with the length of flow paths, maintain natural drainage divide with the flow of the path, to disconnect impervious areas such as the pavement, the roof, and the storm drain network, although running off, allowing runoff to convey in over previous areas instead. Previously natural vegetated areas, soil types of slow runoff by filter out pollutants, facility infiltration, direct runoff into and across vegetated areas to help filter runoff and encourage recharge. Provide small space distributed features, a device that may help meet regulatory resource objectives. Treatment pollutant loads with generated prevent their generation, and low impact devices. Reevaluate the site design once of the appropriate site design strategy if they're concerned with the problem posed to determine whether the stormwater management objectives have been met. Stormwater management control, if required, should be located as close as possible to shore of the potential impacts of the management of the water quality of the pavement, the runoff. For example, should be utilized the device that are installed at the edge of the pavement. The types of the control are generally small scale because of the site planning strategies have created small scale drainage area runoff volumes and can be designed to address very specific management issue with the objective to consider potential every part of the landscape when selecting low impact development device. Low impact devices performance should be into those to the natural system process of the material. Following list briefly defines low impact development devices. Basic list and integrated maintenance practices. Here is the basic list of integrated management practices available. Bioretention, vegetation suppression for collective runoff facilities, infiltration of the ground, dry wells, gravel, stone, filter pit located with the catch water of the runoff downspout of the paved area. Filter strips banned with a dense vegetation plain with immediately downstream of the runoff source designed to filter and runoff the entering of the receiving structure of water body. Grass, swales, shallows, channels listed with the grass used to convey with the restore runoff. Infiltration trenches. Trenches filled with a porous material serve the bioretention material sand aggregated that can collect runoff and exfiltrate into the ground. Inlet pollution removal devices, small storm water treatments that are installed below the grade edge of the paved areas trap with the filter pollutants runoff before entering the storm drain. Permeable pavement, asphalt, concrete with a rendered porous with the aggregated structure. Parable movers of manufactured pavement zone with containing space within the water cannot penetrate with the porous medium underneath. Rain barrels and cisterns contain with the very side of the storm runoff the delivery with the building downspout with the rain barrel with the generally small with the structure located above ground. Certain larger than the off-buried underground may be connected with the building's plumbing integration system. Soil amendments. Minerals and organic material added with the soil will increase the capacity of absorbing moisture for the sustaining vegetation. Tree box filled with the combined with the containment placed below the ground covered with the grate with the fill with the filter media planted with the tree in the center. Vegetation buffer the natural man-made vegetation area with adjacent to the water body providing erosion control, filter capability, and habitat. Vegetated roofs and permeable roof membranes overlaid with lightweight plant mixing with high infiltration rate, vegetated with plants tolerant of the heat, drought, and periodic inundation. 2. Storm management using the hydrological cycle approach. Introduction. Development effect of the natural hydrological cycle. The hydrological consists of the following processes: convection, precipitation, runoff, storage, infiltration, evaporation, transpiration, and subsurface flow. Hydraulic budget describes the amount of the water flow into and out of the area along different paths with some of the discrete until the time of the day, monthly, annually, gradually construct the building, laying pavement to typically affect with a hydrological budget and decreasing rate of the infiltration, evaporation, transpiration, subsurface flow, reduce the availability of the natural shore with the increase of the runoff in natural conditions such as the forest. It may take 25 to 50 millimeters or 1 to 2 inches of the rainfall generate runoff to develop the condition of the very small amount of the rainfall can generate runoff because soil compaction connected with the impervious area with the result of the general increase of the volume velocity of the runoff. Then, in turn, increase the amount of the pollution carried and receiving the waters that amplify the generation sediment suspended soils resulting from bank erosion. Design impact. Design input. Low impact development, conventional stormwater management techniques attempt to control the rates of the runoff using accepted method of hydrological and hydraulic analysis of the particular shape of the characteristics considerable to depend on the natural nature of the product, land use, soil type, slopes, vegetative curve, size of the drainage area, and available storage of the typical site characteristics that affect the generation of the runoff. The roughest slope of the geometry of the stream channel with the key characteristics affect with the ability to convey the water. Conventional approach of the stormwater management design typical include with a hydrological component with the precipitation run and conveying to the storage capacity and with their scope of the low impact development design requirement. We consider significant other component with a hydrological cycle as well, but how these other components with the actual taken into account will depend on the information available for the purpose of the design. One low impact development design object, for example, may maintain natural groundwater recharge rate at the given site with determine the appropriate number of the site location infiltration devices required extending with the atmospheric data set. Temperature, precipitation, calculate the evapotranspiration rates along with a measure of soil hydraulic conductivity. Following section describes low impact development design can be used with the precipitation, storage, infiltration, evaporation, transpiration data, and discuss include with a brief description of each of the type of the data with the compares the use of the data, low impact development, conventional storm drainage management perspectives. Precipitation data. Precipitation data is often analyzed in terms of the frequency of the storm events, different magnitudes, duration occurs at a given location. Storage management design may take into account with its total annual depths, volume generated with the storm, specifically frequency, duration. 2-year, 24-hour storm event hydraulic modules used with the precipitation developed with the synthetic design storm reflects the pattern intensity of the precipitation from the project location region. The use of the actual gauge data from given the storm event, the high level of detail accuracy data with the dependent on the requirement. hydraulic model. For example, develop a simple water balance on-site integration. Only a few years of annual rainfall falls may be required. Some of the advanced urban hydraulic models, on the other hand, may require collection rainfall data in 2-minute intervals over several years. Determine appropriate site system design. Low impact development and precipitation analysis is an important approach for the analyzing effectiveness. Low impact development design consider the number of storms events from which it was designed. Provide enough storage and infiltration with the capacity capture of all precipitation on site. The use of the maintaining hydraulic integrity of the water balance on the site better accomplish managing frequent smaller events rather than occasional large events. For example, the Washington, D.C. region, there are approximately 80 storms events per year, collectively generating approximately 1,000 millimeters or 40 inches in precipitation. Approximately 75 of these storm events generate 13 millimeters or a half inch of less precipitation. Figure 2.1 illustrates the conception. Washington, D.C. Regional National 2000 Daily 1 rainfall net inches. The kind of analysis lab with the design determine the overall storm of the infiltration capacity rate with the control of the design number of the storm events and given the year of the period with the analysis that can be undertaken in its terms. Precipitation depths associated with the discrete storm events such as 1 to 24-hour year period storm. Conventional precipitation analysis. The conventional practice as well as doing with the state local regulations often require engineers to control specific events such as the 2-year 24-hour storm event in Washington, D.C. area would be mean to reducing peak runoff the debris development rates only to those events in which 3 inches of the rainfall events if it occur more than less frequency would be less efficiently controlled. Storage precipitation may be temporarily detained inside depressions held in the soil. The capacity of the depression is exceeded with the water is relieved as runoff that may be captured further downstream, whereas not relief of the runoff is infiltrated with the soil taken up by plants evaporated back into the atmosphere and natural land cover often provides depression storage and small undulation with the topography. Greater storage and capacity provided in ponds and lakes. Alright, low impact storage concepts. Low impact development employs site planning grading techniques that direct maintain flow runoff of naturally occurring storage such as the wetlands, keeping the storage area volume storage stable, help to maintain existing hydrological biological function storage area. With low impact development designs may also include small scale retention components. Retention is defined in volume of runoff that never reaches the drainage and area outlet retention can be provided with a variety of ways on not only support management runoff, but also supply water for the on-site use. For example, the cistern may be used for the storm release water, being flow control as well as the storm water and the domestic purposes. Additional, some industrial buildings can provide roof storage, release water with the use of the cooling system. Another example, in this green wall, with building green wall is used to modify the temperature, improve the air quality, have been stored roof water, flow across vegetation, capture runoff. Small volumes help to prevent erosion because of the runoff of the leaks likely to reach. Damaging flow rates, distributing flow storage components also tend to result with a more robust stormwater management system because of the failure of one component will not cover the entire system fail. Care must be taken with the ponding and storing water to make sure that adequate flow, infiltration, evaporation, discharge, and underwater carrier disease such as mosquitoes are adequately controlled. Conventional storage concepts. Conventional stormwater strategies often include storage water of a large centralized end of the pipe facility storage site is designed direct for the conveyed most often, most runoff quickly as possible. The use facility with then discharge through the outlet structure limited release rate, 2 years, 24-hour to pre-development runoff rate. Conventional runoff management techniques can dramatically reduce flow of the runoff natural storage area, thus with wetland to provide with a variety of organism level of moisture for the need of the conventional approaches and have other negative impacts by removing the opportunity to store the on-site rates of the groundwater recharge will be reduced. In addition, with the concentrated flow conveyed, large-scale facilities accumulate pollutants, increase the erosion force of the water, which may be slowed down, treated to maintain natural energy chemical balance of the ecosystem, increase the temperature as well. The water is will be also detrimental to the ecological integrity of receiving the water. Our infiltration, water stored with the depression infiltrate the soil at different rate depending on the soil, the type of the amount of moisture already in the soil. Some of the water infiltrates the ground, percolate further downward, or aquifer travel horizontally, reappear with source flow in the storm. Portion of the water will be out of soil extracted with the vegetation capacity of the soil to absorb and infiltrate the water depending on the variety of functions. Factors such as the soil structure, pore space, particle size, classification, percentage, sand, silt, clay, biological activity, roots and worms. Water is filtered with the soil system by various mechanisms, subsorption, chemical, biological reaction. Used underwater conditions, a significant portion of annual precipitation may infiltrate into the ground as the land has developed. However, the main natural depression, however, that would otherwise collect water, eliminated soil compacted with improved its air added to the form. Buildings and pavement consequently level the infiltration, typically decrease the site that developed. Additional runoff generated off the site, the result of degradation, water course because of the bank erosion, increase the flooding or alteration of habitat characteristics. Infiltration flow patterns process is extremely important to the maintaining the water balance, wetlands, and base flow of the stream channels. Our low-impact development infiltration concept. The maintaining natural infiltration rate is an important aspect of low-impact development design accomplishment required by the accurate understanding existing soil, ground cover, and conditions. For example, the clay soil pre-development site with a very little infiltration capacity, or sand soil, whose compacted may have reduced capacity for the design, should be taken care not to overload the hydraulic conductivity of the existing soil, but the soil man with the themselves with not sufficient to determine the capacity of the soil will observe. Filter water, additional field testing required to dispersing flow, maintaining natural flow patterns, directing flow towards soil. High capacity infiltration will help maintain groundwater level, amending soil with adding organic materials, reducing compaction, aeration, maintaining leaf in the depth layers, natural air, reducing compaction. Requirements non-loading bearing areas in the hand for the maintain infiltrate patterns. Although soil with a natural air with a high capacity filter treatment pollutants, carefully planning must take place to ensure that the potential pollutants of the nitrate oils and urban runoff contaminants are adequately treated before entering any potential water supply. Infiltration should be not located near area with the potential hazard of waste spills, contamination. It's important to ensure runoff is adequately filtered before and allowed to infiltrate, especially local aquifers, and particularly with a shallow. In this case, water table is very high. It is often advisable to avoid infiltration together. Conventional infiltration concept. The conventional approach for the concentration infiltration capacity of the single end pipe management system, such as a pond infiltration potential elsewhere on the site, but is often discounted. It only one analyzed for its effect on the flow of the runoff of the facility. With the conventional infiltration objective for the concentrated flow area is one area Then utilize the infiltration capacity of the natural soil conduits of the gravel, the natural groundwater, the flow patterns, recharge often not considered. Conventional approaches may result with elimination critical volume flows sensitive to the area such as wetlands. Additional may be in urban areas, high loads. Find some that centralized facility with the impact for the construction compaction. Conserve here. They limit the infiltration capacity of the facility. Evapotranspiration, loss of water with the ground, evaporation, and the evaporation, return of the moisture, atmosphere, depression, pond area, and other surface. Transpiration is the return of water to the atmosphere through plants, moisture absorbed by roots, and the release through the leaf. The rate of the evapotranspiration is depending on the air temperature, humidity, wind speed, sunlight intensity, and vegetation and soil conditions. Low impact development evapotranspiration concept. Low impact development design use the open areas vegetation promote evapotranspiration. Large areas of use of evapotranspiration such as ponds should have flow regimen controlled mosquito bear eating. Low impact development design should not pond water for more than 72 hours to provide with the opportunity for the mosquito to breathe. Keeping soil for the air, small shallow water can quickly evaporate pollutants volatilize with the plant uptake of evaporation. Low impact development also employs capacity vegetated areas observe the process of volatilize and treat non-point surface pollution as well as atmospheric pollution. Interception with the leaves can significantly reduce the requirement of storage. Infiltration mature with the canopy can intercept a specific number of small volume frequently occurring storm and absorbing precipitation into the plant leaves. Precipitation from the leaf surface. Additional uptake of the soil moisture by plants helps to maintain soil capacity to absorb rainfall. 262, a conventional evaporation concept with conventional stormwater approaches areas based on peak flow control over short duration, usually 24 hours or less. For these signal event designs, evaporation process is often discounted and not considered. Chapter 3, Low Impact Design, Feature, Goals, and Objectives. And we're going to cut the tape there.